Hey guys, this is Karan here, living in Saudi Arabia, studying 10th grade in Yamgo International School. Sequences can be thought of as an order of list, numbers. So let's take some examples to understand the concept of sequences. So for the examples we have, let's say first is 2, 4, 6, 8, 10, and then goes on forever. Second example could be in fraction, could be in fraction. The third one could be just in numerals. And this, to be honest with you guys, is most used. Okay? We'll understand why in a bit. Then it's a to the 0, to the 1, to the second, to the third, and so on. So here are some series that we can use. The items can be generated in numerous ways, such as listing like we saw here, and continue with the listing of the pattern, continue with it, goes on forever. But a lot of time pattern is just an example to show. Okay, so we need to become handy. We can't just solve till whatever the quotient asks for. What if the quotient asks for 100 term? We might not have that much time on the test to solve for it, right? So we come up with a formula such as this. Okay, let's say for example if it's an to n minus 3. Well, the first one, a1 is equal to 2 times 1, which is a1, right? Minus 3, now it's equal to negative 1. a2 is equal to 2 times 2 minus 3, which becomes 1. Then a3 would be equal to 2 times 3 minus 3. 6 minus 3 is still 3, right? Then a4, as we move on, is equal to 2 times 4. 8 minus 3 is 5. Then a to the 10th, if we move on to 3, so times 2 10s are 20. 20 times minus 3 is equal to 17. Okay, so you see it's very handy when we have a formula towards it. Okay, so let's see something which we have something like this. So this pattern that we just formed can be a pattern of this sequence, which looks like negative 1, 1, 3, 5, and goes on forever. This is the pattern of this series, and we can conclude that after this we have 2n minus 3 and blah blah blah, so on. Okay, so let's go on to the next example. It's fairly easy once you understand the whole concept behind it. Okay, so if you have a n is equal to 3 plus 2 times negative 1 to the nth power on the exponent. What happens then? Well, a first would be 3 plus 2 times negative 1 to the first power, which basically is equal to 1. Try it out, you can do this. I solved this already. 3 plus 2 times negative 1, the squared is equal to 5. A to the third power is equal to 3 to negative 1 to the third power, which is equal to 1. Again, a to the fourth power is equal to 3 plus 2, negative 1 raised to the fourth power, which basically is equal to 5. So you see the pattern is repeating and repeating again as you move on. Now the sequence for this would look like something like this. Okay, and the formula that we use is this one over here. Okay, but in some expression we need to generate expression that is associated within the certain sequence. This can be thought the toughest thing that we can do in the study of sequence. So let's go ahead and use the pattern and build up the equation like this. Because if we just come across this, we might think that you have to add 4 to it, so on. But no, you have to use this equation. Okay, so let's we work towards the right. Now let's go backwards, okay? We're gonna switch gears within the topic. Okay, so let's see. For example, we have 1, 4, 9, 16, and 25. Okay, and the n term we find out to be 1, 2, 3, 4, 5. You multiply each side by that and you get the answer. Okay, so basically what's happening is that 1 squared is 1, 2 squared is 2, 3 squared is 9, 4 squared is 16, 5 squared is 25. So we need to identify this. So this is the n term we are using here. Okay, and the formula that we generated right away is that, after noticing a pattern, is that an is equal to n squared. So for the first value we have 1 that is being squared. To find the a first, well, a first is still 1. Yep, that matches. Let's go for the second one. The second one is 2. 2 squared will give us the a's to the second series, which gives us 4. True. So yep, this formula that we generated is true. Okay, this is all you need to do is pay attention to the sequences to find out. Okay, and it turns out that it's not really easy. Okay, at first it's not really easy, but once you get used to it, you identify the patterns a lot quicker than before. Okay, so you have, let's say, 2, 5, 10, 17, 26, and so on. What happens then? Well, then n, we find out that 1, 2, 3, 4, and 5. Now, could you identify something? Well, what it is basically what we did is I just used the thing that we used before and added something to it. Okay? So what I did is a to the n is equal to n squared plus 1. So the first one, a to the first, would give us 4 squared plus 1, which gives us 2. Yup, that's correct. Second one is equal to 2 squared plus 1. 4 plus 1 is equal to 5. Yup, that's correct. So the formula that we generated is correct. Okay? Now notation that are involved in sequence is factorials. Factorial notation can also be expressed like this. Let's move on to factorials. Okay? A factorial notation can be look something like this. 5 factorial, which basically means that 1 times 2 times 3 times 4 times 5. Okay? Now that, or you can write it backwards, 5 times 4 times 3 times 2 times 1. Either way, you're going to get the same answer to be 120. Now you can do this by yourself or in the calculator. Okay? Most of the people use a calculator. But this one interesting thing, what is the 0 factorial? Well, 0 factorial is 0. Okay? It's not 0, it turns out that it's 1. Okay? It's like saying any number raised to the 0th power, which gives out 1. The same way, a 0 factorial gives out 1. Okay? So you might want to remember this as you move on. So, let's move on to something that involves factorialization. So, there's a formula of factorialization when it comes to series is that n plus 2 factorial divided by n factorial. Now we can break this apart and go like this. N plus 2, n plus 1, n factorial. All divided by the n factorial. Now you see something is matching. The n factorial and n factorial. So what we are going to do is cut this out. And what we have is basically n plus 2 times n plus 1. Okay? So this is how the factorial notation works. Now we are going to move on to summation notation. Okay, now sigma notation is what mathematicians call it. Okay, so how does the sigma notation look? Well, looks like this. This is the representation of sigma. And it's mostly used in physics, study of physics. Okay, but it also helps in mathematics because mathematics and physics are interrelated to each other. So if you have something like this, it says 3 on the top, k is equal to 1, then the quotient says 2k plus 1. Okay, what are you going to do? Well, before we actually go on and solve this, what I want you to do is to understand this concept. The 3 over here is the limit, and this over here is the index, low limit. Okay, so all this thing says is that for the value of k, replace 1. Okay, so 2 times 1 plus 1, and then we move on and keep adding up to 3. What do I mean by this? Let's go ahead and solve it. Well, this one, the first one would be 2 times number 1 plus 1 plus 2 times 2 plus 1 plus 2 times 3 plus 1, and then we stop because the limit is still 3. So we did it till 3. Now we solve each and every bracket and you get the final answer. The total, summation always means the total. Like in physics, it says summation force, which basically means the total force in whatever direction you're moving. 3 plus 5 plus 7, which yields 15. Okay, so the summation notation for this is 15. The total answer for this is 15. Let's go ahead and solve another one to get the hang of it. It might look confusing at first, but it's really not, trust me. So the second one we are going to use is 3 when n is equal to 1. And then it's 4n. So how you're going to do this is 4 times 1 plus 4 times 2 plus 4 times 3. Then we stop because this is the limit. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. Add them up together, you get 24. Simple as that. Then let's go on to something which is more interesting. It says 3 on the top equals 1, then it has 4 over here, and n is equal to 4. Okay, and n over here. Well, basically, these are same thing as we talked about, which basically means the 4 times n. Okay, if the 4 is over here, it's just put in the order that it's confusing you. What we did previously is the same thing. This equation basically is equivalent to saying like this: n is equal to 1 when 4n. Okay, it's just put in the order that it's more confusing. So this would multiply times n. So in this equation, what you have when you solve it, it's like this. We're going to switch markers here. Okay, so you would do 4 times n, which is all these terms, then you multiply it. Well, 4 times 6 is the total, which gives us 24. It's a rather simpler way than adding all those terms together, okay, and getting the answer to be 24. So it's just put in this order to make it more simpler, but it looks confusing at first. Okay, that's basically the whole point of this whole tutorial, to make it easier for you guys. Let's go and solve our last example on sigma notation, and then we'll continue that next series in our next video. When k is equal to 1, 3. Okay, so what I mean by this, now there is no k. Since there is no k, this is a peculiar case because this is involving no k in it. Now since this is not involving k in it, what we need to do is add 3's 4 times. Just 3 plus 3 plus 3 plus 3, which gives us 3 times 3 plus 3 is 6 plus 6, which gives us 12. That's the answer. Okay, this would make it more confusing right here. To 100, and then you have zeros to when k is equal to let's say 1. The answer would be 0, because all you're doing is adding zeros 100 times, and which yields 0, so the answer would be 0. Okay, nothing really hard in this section. So what I want you guys to do is, if you enjoyed this video, give it a like, comment and subscribe on how my videos are going on. Give me a feedback, even if it's positive or something like that. And what I want you guys to do, I insist you guys to help me out here, is that there's a URL of Facebook page down below in the description area. Click on that, give it a like, comment and on the Facebook page, and that's it. Thank you for watching. Peace out, guys.